Alright, in this video we're going to go over compound interest, which also has to do with geometric sequences. And the best way to go through this is go through a typical IB problem. This is a paper 2 problem. So it says on Vera's 18th birthday she was given an allowance from her parents. She's given the following choices. Choice A, $100 every month of the year. Choice B, a fixed amount of $1,100 to be invested at an annual rate of 12% compounded monthly. C, 75 for the first month and an increase of 5 every month thereafter, and 80 the first month an increase of 5% every month. Okay, so this kind of takes into account a lot of the stuff we've done with arithmetic and geometric sequences. Part A says, assuming that Vera does not spend any of her allowance during the year, calculate for each of these choices how much money she will have at the end of the year. Okay, so let's just start off one at a time here. We'll start with choice A. Okay, and choice A is pretty simple. It's 100 a month for 12 months. So you just, do 100 times 12, and you get 1,200. Okay, that's pretty simple. Now, if it's simple, it's probably not going to be the right answer, but we'll see. All right, let's do B here. All right, a fixed amount of 1,100 to be invested at an annual rate of 12% compounded monthly. Okay, well with this you're going to want to use the compound interest formula that's in your formula booklet, and that formula is the future value equals the present value times, let's see, 1 plus the interest rate over 100 times k, all to the kn. Now this looks kind of complicated, but it's actually not that bad. What this is, okay, so future value is FV, present value, R is the interest rate, K is the number of compounding periods. So if it's a yearly, you just leave it alone, it's 1, but like for instance if it was quarterly you would put 4. In this case, what does it say, monthly, so we're going to put a 12. So I'm just going to put, we just want to see what our future value is going to be. So the future value is going to be, she starts out with $1,100 times 1 plus, what's the interest rate? 12% interest over 100 times 12, all raised to, now it's 12 compounding periods and it's just 1 year, so it's going to be raised to the 12th power. Now if you were to simplify this, you would get 1,100 times, okay, what's that? Let's see, 12 over 1,200 is 0.01, so plus 1. So if you do all that in the brackets, you're going to get 1.01 raised to the 12th power. Now we can bust that out on the calculator and we can just enter it in. Let's clear this out here and get 1,100 times, and then I'll put the 1.01. You don't really need to put it in brackets, but I'm going to do it anyway. Just a good habit to get into, and then raised to the 12th power. So let's see what we got there. Okay, 1239.51. Now this is dollars, so you're going to go to 2 decimal places. So future value is 1239.51 in dollars. Okay, now you can see that that's better than 1,200 for the first one. Now choice C, let's see, it says 75 for the first month, an increase of $5 thereafter. Okay, that's an arithmetic sequence. Okay, so we can use the arithmetic sequence formula to get our sum, because they want to know how much for the year, right? So remember that this is n over 2 times 2 times the first term plus n minus 1 times d. Now, I mean, you could add them all up if you want, but this is much quicker. So the sum of 12 is going to be 12 over 2 times 2, now the first term is 75, plus 11, 12 minus 1 is 11, and then d, what's d? 5. Okay, so it's only going up by 5 per month, but it will add up quickly. So this is the sum of the first 12 is going to be 6 times, let's see, that's 150, 205, right? 150, I should probably use the calculator, 205, and so that's going to be $1,230. Okay, so that is actually lower than the one before, so we don't want that one. It's actually lower than part B. Now, for part D, okay, 80 for the first month, an increase of 5% every month. Okay, well, that's a geometric sequence. It's increasing 5%. Now, the only trick with this one is basically, okay, so it's a geometric sequence. We're going to go, we can use the geometric sequence formula, which is the first term times the ratio to the nth term minus 1 over r minus 1. Now, in this case, it's going to be the 12th term. The first term is 80. Now, the ratio in this case is kind of tricky. It's going up by 5%. Now, you can't do just 0.05 or 5. What this is if you actually put it into this formula here, the 1 plus 0.05, the ratio for this is going to be 1.05. Now, okay, 1.05, what is it? Raised, hold on, let me just put a bracket there. Raised to the 12th power minus 1 all over 1.05 minus 1. Now I'm kind of running out of room here. Let me show you why that is. Okay, if the first term is 80, and 5% of 80 is 4, so the next term would be 84. If you divided those, 84 divided by 80, you'd get 1.05. Now I know that's a little tricky. Some kids get confused on that. But I guess a shortcut for that is just to add 1 to the decimal. Okay, so we'll break out the calculator here, and we'll clear it out, and we'll get 80 times 1.05 raised to the 12th power minus 1. Okay. And that's going to be some big number, probably 63.66. Okay, fine. And then 1.05 minus 1 is just 0.05, so we're going to divide it by 0.05. And so it's going to be 1273.37. So 1273.37. So 1273.37. Okay. Now, if you were to look at these, if we're going to look at all these totals, let's look what we got here. We got the first total. Where's my pen? Oh, there it is. Okay, we have what, 1200, and then the second we have 1239.51. The third we have 1230, and then we have 1273.37. So obviously it says part B, which of the choices do you think Veer should choose? Well, obviously you would choose 1273.37 because it's the highest one. Now, you got to be careful on this. I was talking about this with some of my students, and they're like, well, I would choose the 1200 up front because, or the 1100 up front because I'd spend it quicker or whatever. And you don't want to use that kind of logic on these tests. They don't know your parents, so just go with what is right. One person was talking about giving money to charity. That was awesome. And yeah, while a noble effort, probably not going to work. All right, let's move on to the third part of this problem. Okay, so the third part says on her 19th birthday, Vera invests $1,200 in a bank that pays R% interest per annum compounded annually. Vera would like to buy a scooter that costs $14.52, or $1,452 on her 21st birthday. What rate will the bank have to offer her to enable her to buy the scooter? Ooh, I spelled buy great too there. That's awesome. Okay. Now, what I'm going to show you how to do on this one, if you solve it using the formula for compound interest, is actually going to be more difficult because you're going to have to use logarithms or a square root. So what I'm going to show you is on the calculator. If we take our calculator out, what you can do here is you can go to apps and then finance, and then TVM solver. Now this will be on your calculator. They can't remove it when they clear your calculator for a test. Now the beauty of this is that this is going to solve for us. So it says she invests $1,200. Well, that's the present value. $1,200 is PV. Okay, so for PV, now because she's giving them $1,200, you have to put this as a negative number. Okay, now it's kind of a weird thing, but if you don't do it that way, it's not going to work. So that becomes negative. It's because she's putting the money up for it. I guess that's one way of looking at it. Now the future value, what does she want for the future value? Well, she wants $1,452. Okay. Now, okay, so 19th to 21st birthday, so that's 2 years. So you're just going to put N right here for 2 years. Now, PY is payments per year and compounded yearly. This is, the interest is calculated per annum, per year. So we don't have to change these. If it was quarterly, this would be a 4, and that would be a 4. If it was monthly, it'd be a 12 and a 12, and I'll do another problem like that some other time. So what we want to calculate is the interest rate here that she needs. So the way to do this is you just use the solver. You go to alpha, which is, well, it's the green button on the TI-83. What color is it on the TI-84? I can't remember. Anyway, alpha, and then solve, which is the enter key. And you'll see that it's 10%. Okay, now what I would do here, if I were you, is I would just, if you're going to show your work here, I would show, I would show what the calculator says. So the interest rate is, 10%. The present value is negative 1,200. Let's see, what else do we have? I wish it would stay up. And then payment is, that's always going to be 0. Okay, and then the future value is, what she wants, how much money she wants, 1452. And then payments yearly, which is just 1, and compounded yearly. I would write this on your, just, put a box around it. And so the person who's grading your exam knows exactly what you're doing, that you're using the solver. And that's a totally valid method of doing it. And it's actually very easy. If you get to the solver, solving for a future value with the equation is easy, but once you try and find N and R, it's not easy. You have to use logarithms or, square root. There's a lot of algebra involved. So I would highly recommend that you get good at the solver. And again, to get there, you just go to apps, you go to finance, you go to TVM solver, and then there's going to be basically 4 things: N, the interest rate, the years, present value, future value. They'll give you 3 out of 4 of those, and you solve for the other one. Now the only other thing is you might have to change the PY and CY, but we'll bust one of those out later. Anyway, hope this video helped. It's running a little long, so I'm going to cut it short. Hope there's not too many mistakes. If there are, oh well, no, I'm just kidding. I'll check. All right, take it easy. Later.